The MiG-29 tactical fighter. Takeoff into the future. The story of a modern aircraft begins long before it takes to the sky. Before the first flight comes the experience of earlier generations and scientific knowledge and the talent of engineers and designers. An aircraft can only become unique and special by utilizing the best. The aircraft's face is its aerodynamic shape. Its clothes are the subdued colors of the fighter or the bright hues of the aerobatic team. The aircraft's heart is its engine. Its mind is the vision of the people who created this miracle of technology. And the brain of the aircraft is a network of cables and electronic diagrams with a pilot at their head. In aircraft, as in humans, everything should be functional. Face, clothes, mind, and thoughts. Episode 1, Factors of Success. The design of the MiG-29 tactical fighter bomber started in 1970. That was a time when the very concepts of aerial combat were changing. The new thinking was sparked by the military conflicts that were happening as the 60s became the 70s. Air combat was a big part of those conflicts. It's worth mentioning that one of the protagonists had always had Soviet aircraft in its military service, especially MiG fighters. In fact, in the second half of the 20th century, it was hard to envisage aerial combat without aircraft from the MiG factories. The MiG Experimental Aircraft Design Bureau had always been a world leader in combat aviation. The history of the MiG Bureau is significant because the success of the MiG-29 owes much to the Bureau's past successes. In the mid-1930s, the main Soviet fighters were the I-15, which was a biplane, and the I-16, a monoplane. They'd been designed under the supervision of Nikolai Polikarpov in what might have been the only fighter aircraft design bureau in the Soviet Union at the time. The Spanish Civil War provided a serious test of the combat capabilities of the Polikarpov fighters. It soon became clear that they needed to be replaced urgently. Their nemesis was a new generation German fighter, the Messerschmitt 109. In 1939, a group of designers from the Polikarpov Bureau developed a project for a high-speed, high-altitude fighter. It was to be designated I-200. On the 8th of December 1939, a decision was taken to set up an experimental design department at the Aircraft Plant No. 1 to proceed with work on the I-200 aircraft. Artyom Mikoyan was appointed department chief and Mikhail Gurevich his deputy. This was the start of a new aircraft design bureau. Artyom Mikoyan and Mikhail Gurevich made a very good team. Mikoyan was a wonderful organizer and Gurevich was a brilliant engineer. Their long-term creative union produced generations of aircraft that were outstanding in world aviation. The first of the Design Bureau's I-200 fighters made its maiden flight on the 5th of April 1940 in the hands of test pilot Arkady Yekatov. In December, the fighter was designated MiG-1 for Mikoyan and Gurevich 1. The MiG-1 and its updated version, the MiG-3, played an active role in the Second World War. They were pivotal in defending the skies over Moscow in the dark days of 1941. With the coming of the jet era, the MiG company became hugely successful. These are the steps along the way. MiG-9, the first jet fighter in Soviet Army service. MiG-15, the first Soviet swept-wing fighter. More than 17,000 of them were built, making it the #1 jet fighter. MiG-17 flew in conflicts all over the world. MiG-19, the first supersonic Soviet fighter. MiG-21 flew at twice the speed of sound. When you consider the number of versions, there's no other aircraft to compare. It served in the air arms of 49 countries. MiG-21 fought over Vietnam. The US Phantom was its main opponent there. In the Arab-Israeli War, it was up against the French Mirage. These dogfights caused a rethinking of frontline fighter operations. It had been thought that close air combat was history and that airborne radar and guided missiles were the future. But it became clear that in opting for speed, the fighters were losing out on maneuverability. And in practice, it turned out that it was those old close maneuvering dogfights that won the day. An update to the latest MiG-23 was the first response. It had a variable sweep-back wing, and that gave it flexibility in close combat. But it was not enough. What was needed was a completely new fighter. We well understood that we had to build an aircraft to keep up with American fighters. Also, it had to be better in terms of further modernization and upgrade. There were so many tasks to solve. We had to automate close aerial combat, because today it's very fast and it lasts just a few seconds. Plus, we needed reliable weapons for close air combat. The specifications for an advanced fourth-generation frontline fighter for the Soviet Union were worked out in 1971. To perform combat missions successfully, the new aircraft had to be qualitatively different from its predecessors. The priorities were high maneuverability, a more or less new flight system, and up-to-date air-to-air weapons systems. In fact, it was a new concept in combat aircraft development. The plan later resolved itself into two separate projects, and the Soviet Air Force got two great fighters, the heavier Su-27 and the light MiG-29. People sometimes try to compare these two, but it's apples and oranges. Each one had its own niche, even at the design stage. It was designed as a more mass-produced aircraft with a smaller combat radius of action. But the fighters are similar in other ways. The Americans also created their own aircraft pair, the heavy F-15 and the light F-16. Many more differences between them. Often the F-16 is compared to the MiG-29. Alexander Chumachenko was appointed to supervise the MiG-29 project under Rostislav Bilyakov. He'd become head of MiG the year after Artem Mikoyan's death in 1970. Two layouts were considered for the fighter. One was like the earlier reconnaissance interceptor MiG-25. In its day, the MiG-25, with its unique steel structure and its top speed of 3,000 kilometers an hour, was a great scientific achievement. In fact, a world altitude record is still held by the MiG-25. The MiG-25 layout was considered unpromising for a maneuverable frontline fighter. Instead, they went for an integral layout where the wing with a filleted root formed a single lifting body with the fuselage. That decision made a huge difference to the maneuvering performance of the new aircraft. The wing was fitted with a leading-edge droop flap, and that enhanced the lift capacity of the wing. Two vertical fins gave the MiG-29 better stability at high speed. The engines and their air intakes went under the lifting body, and that also improved combat performance. After millions of calculations and experiments at Sagi, General designer Rostislav Bilyakov approved the integral layout for the MiG-29. In September 1973, our general designer appointed me as a MiG-29 principal designer. The work was very interesting. That was a job for real men, I'd say. The MiG-29 fighter is a breakthrough in our technology, in our science, our aircraft design, and our aerodynamics. It's a conceptually new aircraft in all respects. The design called for new materials in the structure. The traditional aluminium alloys were partially replaced by carbon fiber composites. You could see it on unpainted aircraft. The carbon fiber bits are grey. These light but very strong composites have become indispensable in modern aircraft construction. Nowadays, they're an essential part of the fifth-generation T-50 Russian fighter. But it was the MiG-29 that pioneered their use in Soviet aircraft. For high maneuverability, the new fighter needed new engines. It was decided to have two. Compared to single-engine configuration, two engines offered higher survivability. Combat experience showed that if one engine failed, it was possible to continue with the other. The engines were housed in separate nacelles some distance apart, and that also enhanced survivability. It's worth noting that the US F-16 has only one engine. One of the most important tasks in MiG-29 development was the power plant. We had to answer the question, what engine should we choose? Eventually, we had a unique engine that could operate at any G-load, any speed, and with any turbulence in the engine intake. This is the first aircraft in the world with no engine limitations for the pilot. The pilot controls the engine the way he needs to. The engine for the new MiG was developed at the factory named after the engine designer Klimova. Sergei Izotov was a chief designer. The engine was designated RD-33, a bypass turbojet with an afterburner. It was lighter and more fuel efficient than its predecessors. The RD-33 weighed a ton and produced 8 tons of thrust. That meant that the aircraft thrust-to-weight ratio was greater than 1, and the total engine thrust exceeded the aircraft's takeoff weight. This engine performance means faster acceleration and more agility under high G-load. It also means higher rate of climb and, in the end, superiority in air combat. They started building the prototype MiG-29 in 1975. A year later, the engines had been designed. They were flight tested on the flying testbed Tu-16. The MiG-29 started test flying in autumn 1977. 11 years of painstaking work, numbered in days and hours and minutes and seconds and even milliseconds, ushered in world triumph for the MiG-29. Its maiden flight was on the 6th of October 1977 in the hands of the chief test pilot of the Mikoyan Design Bureau, Alexander Fedotov. We wanted to see the result of our work. From the first flight through all the flight tests, we were waiting to see the proof that we'd done everything right. There was complete silence when the aircraft landed. I shouted, "Hooray!" and threw my hat in the air. After the first flight, Fedotov was very emotional. The aircraft was easy to control, its capabilities were unlimited. Thumbs up, he said. This is a unique aircraft. Once I dreamt I saw one like this. Funny thing is, the aircraft I saw has become real. Early on in testing, the engines were the main problem. They didn't develop their planned thrust, and at the same time, they were not reliable. One failure followed another. It's not unusual for engines to create more problems than the aircraft itself. As a rule, it takes longer to develop a new engine. It all kicked off in the summer of 1978. On the 15th of June, test pilot Valery Minitsky was doing a scheduled test flight in the second flying prototype. Alexander Fedotov was flying chase in a MiG-27. From Valery Minitsky's published memoirs, "You're on fire." Fedotov sounded unusually serious. He didn't explain what was on fire or where it was. He just said, "You're on fire." The aircraft began slowly pitching up, and then suddenly it pulled G. It looked like a wild horse trying to shake off a rider. "10 kilometers to go to the runway, 800 meters to the ground. It's time." I grabbed the ejection handles and pulled them. I remember it very well. I was sitting next to Arkady Slobodsky. We were doing paperwork. Suddenly one of the navigators rushed in and said, "Minitsky ejected. The aircraft crashed." What? How did that happen? We tried to make our engine as light as possible. The compressor was titanium. When it's burning, it's very difficult to put out. I don't know any system that can do that. Titanium burning temperature is about 2,500 degrees Celsius. First, the engine's second support was destroyed. Titanium compressor parts started rubbing against each other, and a fire started. It destroyed part of the control system. The aircraft became uncontrollable and pitched up. When it began to descend, the pilot realized there was nothing he could do and ejected. In October 1980, another aircraft crashed because of engine unit damage. Fortunately, no one was hurt. Alexander Fedotov ejected from the aircraft 3 seconds before it hit the ground. There are special tests when an aircraft gets near its performance targets. We have to test it to the limit and even further. We tested one close to 1,500 kilometers an hour. At that time, no aircraft could achieve such a speed. At 1,360 kilometers an hour, a combustion chamber blew up. These are just some episodes from the aircraft early tests. This kind of accident usually gets a lot of attention, and it's difficult to forget. It's often a cause of emotional and physical tension. The aircraft did have some problems, as any new aircraft does, but I have to say that when we flew it for the first time, I mean both Fedotov and myself, then my colleagues, we immediately noted its superb lift-drag ratio and wonderful power-to-weight ratio, which up to now is unsurpassed. So at that time, the most important features of the aircraft were apparent in all their splendor. And of course, its quality. There was talk about first or second generations. Everybody was confused with the generations. But when we saw the MiG-29, and it was the predecessor of the Su-27, we realized that they were both aircraft of quite a different generation. Significantly, the MiG tests didn't result in critical changes. Modifications were minimal. Interesting to note that the Su-27 was almost completely redesigned after its tests started. On the MiG, the quantity of carbon fiber parts was reduced and the nose landing gear strut was moved backwards. In 1982, the other chief aircraft designer, Michael Faldenberg, took over and was appointed chief designer. 14 aircraft were involved in the flight tests. Some carried out flight performance assessments, while others flew tests on engines, onboard equipment, and weapons. During the test program, I had to check the MiG-29's maneuverability. I remember my first MiG-29 flight very well. I took off and put the aircraft into level flight. Then I made a turn to see how it went. Slight pressure on the stick, the aircraft turned easily. I increased thrust, the aircraft started turning like crazy. I thought, goodness, I've got to stop or I'll get dizzy. So I went back to straighten level and waited a bit. I'd never flown an aircraft like this before. It's a real tactical fighter, a fighter perfectly designed for air combat.
Действительно, истребитель, фронтовой истребитель для воздушного боя.
The MiG-29 flight tests were complete by 1983. They'd taken 3.5 years and almost 2,500 flights. The aircraft demonstrated superb maneuvering and combat performance. Single-seat MiG-29 tactical fighter, type 912. Length 17.3 meters, height 4.7 meters, wingspan 11.3 meters, maximum takeoff weight 18,100 kilograms, maximum speed 2,450 kilometers per hour, range 1,430 kilometers, service ceiling 18 kilometers, maximum G load 9G. The MiG-29 was simple to fly, was capable of minimum turn radii and high angles of attack. The rate of climb was 330 meters per second, better than the US F-16 and F-15 fighters. In the summer of 1983, the first aircraft went into Air Force service. My first impression was that I'd entered a new dimension. I'd found myself in the future. The MiG-29 was completely different from anything I'd flown before. It was something extraordinary that I'd never before experienced. I would say this fighter was a revolution. It was something I couldn't even have imagined before. When I first took off in the MiG-29 and made the first turn at full thrust, I realized that the aircraft was flying a very tight turn. I was amazed. I really loved it. I realized right away that this fighter was a completely new type of aircraft. I was highly impressed with its maneuverability. It seems to make no difference whether you fly with the landing gear down or up. What's the difference between this MiG fighter and other combat aircraft? Superb ergonomics. The cockpit is so well designed, the pilot feels very comfortable. It's just like your workroom. Everything's close at hand. The MiG-29 cockpit is designed exactly like that. We often called the MiG-29 the soldier fighter. It's the embodiment of air combat. This is the present day at the Russian Air Force Combat Training Center at Lipetsk Air Force Base. A new generation of pilots is flying the MiG-29 fighter. It's still making them happy. The MiG-29 cockpit's very comfortable and ergonomic. The pilot can easily find any switch, any selector, and it's also very easy to reach any switch in the cockpit. The instrument panel is split in two halves. One has the flight and navigation information, the other contains engines and systems control instruments. There's a head-up display above the instrument panel. Among other things, it provides sighting and aiming for both air and ground targets. The pilot's main aircraft control device is the control column, and it's got a brake lever and two triggers on it. One trigger releases bombs and launches missiles, and the other fires the gun. There's a pair of levers on the left side. They're engine throttles. Now they're in the idle thrust position. You push them forward to increase the engine thrust. If you need afterburner, you press a button on each throttle and push it forward as far as it will go. The air intakes have got special ramps and spill flaps in them. They control the amount and speed of the air flowing into the engines. An automatic system operates them according to aircraft speed and altitude. The air intakes also have doors which prevent foreign object damage.
Которая защищает двигатель от попадания в него посторонних предметов.
The door closes when the engine starts. It protects the engine from foreign objects getting inside when the aircraft's moving on the ground. The air gets in through upper inlets. During takeoff, the door opens and the upper inlets close at 200 kilometers per hour. On landing, everything happens in the reverse order. As soon as the engine stops, the door opens to give access to the engine. Ground crew also rated the aircraft highly. The technicians liked the simplicity and the convenience of the MiG's maintenance procedures, even including engine replacement. On most Soviet aircraft, changing an engine was time-consuming and labor-intensive. You had to disconnect and then reconnect lots of pipes and cable looms, and most of them were hard to get at. On the MiG-29, it's all much simpler. Some of the technical design of this aircraft significantly reduces the maintenance time. For instance, engine cowls designed specially for the aircraft make taking the engines out much quicker. The cowls make the access much easier. Now you can replace an engine in just a few hours. That's important in tactical fighter maintenance. The access hatches are very easy to reach, so the MiG-29 needs less time for maintenance than earlier combat aircraft did. This is how they replaced the 3 landing lights on the aircraft. Putting in a new braking parachute takes just a few minutes. This parachute halves the landing roll distance to about 750 meters. Obviously, for the first years of the MiG's service life, it was kept under top-secret wraps. It was, after all, the time of the Cold War. Any leaks could have undermined the country's defense capacity. That had already taken a bad knock when Senior Lieutenant Viktor Bilyenka hijacked a top-secret MiG-25 to Japan. Western intelligence services were keen to see the new Soviet aircraft. Orbit by orbit, NATO reconnaissance satellites were combing the Soviet Union territory. So the MiG-29 prototypes were carefully hidden. Tests were conducted between satellite flyovers. The NATO code name for the MiG-29 was Fulcrum, meaning pivot. The fighters were made in Moscow, and final assembly and flight testing were done at Luchowitz town in the Moscow region. Production of the 2-seat version started at the Gorky plant. All of these activities were top secret. Each factory had schedules of foreign satellite flights. They used this information to plan times to roll the MiG-29s out of their buildings. Before going outside, the fighters got false wings and noses to make them look like MiG-25s. Outside and in, the MiG-29 and its weapons control system were attracting much interest. The MiG-29 radar was developed at the Phasatron Research and Design Bureau. This radar can detect a hostile aircraft or missile up to 60 kilometers away, and at the same time, it can track up to 10 targets at once. Another important component of the targeting system is the COLS infrared search and track device. It's got a heat seeker that detects targets from the thermal radiation that mostly comes from their engines. And the range to a target is established by a laser rangefinder and target designator. A target designation system that was mounted on the pilot's helmet was developed. Once the pilot has seen the target, he or she tracks it by turning his or her head, and this provides target designation for the missiles. It's intended for close air combat. And incidentally, systems like this only appeared on Western fighters in the 1990s.
Когда шло объединение Германии,
With the reunification of Germany, the Luftwaffe and the Bundeswehr were finally able to examine every aspect of the MiG-29. They came, they checked the aircraft in minute detail, and they concluded that no country in the world had ever had such a great fighter. This is Playboy magazine. In an article, a German pilot says, "This is an excellent killer. Using his helmet eyepiece, a pilot can control his missiles simply by looking at a target." At that time, no aircraft, including Typhoon or F-18, could escape the MiG-29 in close air combat. I'm not even going to mention Tornado and Jaguar. As the article says, for the MiG-29, these two aircraft were saved to the end.
эти самолеты были для МиГ-29 на закуску.
An important component of the MiG-29's capabilities was the variety of missiles specially designed for fourth-generation fighters, in particular the R-73 missile. The R-73 is a close combat guided missile with an infrared homing head. For a long time, there was no missile like this. It has a thrust vectoring engine, which gives it phenomenal maneuverability. Immediately after launch, the missile can turn through 90 degrees. Doesn't have to keep the aircraft pointed at the target. All he has to do is watch it through his helmet sight. You can't dodge an R-73 in close combat. The missile range is anything between 300 meters and 30 kilometers. The R-27 medium-range missile is for longer distances, up to 70 kilometers. Here's an interesting point. As soon as the MiG-29 was built, it was fitted with short and medium-range missiles. Its counterpart F-16 started with short-range missiles and could only use its weapons in visual contact conditions. The weapons carrying capacity of the MiG-29 is the same as the Su-27s, except that it carries fewer missiles. Carries 3 under each wing. In fact, the MiG-29 set a new standard for light fighters. It's actually a multi-purpose short and medium-range air combat fighter. The gun is a 30mm Gescher single-barrel cannon designed by Gryazev Shipunov. It fires 1,800 rounds a minute, and the magazine holds 150 rounds. It can be used for either air or ground targets. The MiG-29 can also carry bombs and rockets. These are 250-kilogram bombs being loaded. And these are 80mm rockets. Each underwing unit holds 20 of them. The MiG-29 went into squadron service in large numbers from 1986. By that time, a two-seat trainer version, the MiG-29 Ube, was being developed by the Design Bureau. The addition of the second crew member meant that the radar was not fitted, and therefore no medium-range missiles could be carried. In all other respects, the two-seater was as good as the single-seater. The rear cockpit has special instrumentation for the instructor to simulate different types of aircraft failure. They put a periscope in so you could see better from the rear cockpit. Not quite like a submarine periscope, perhaps, but it does have a system of mirrors. It's used during takeoff and landing, and it lets the instructor see the runway in front of the aircraft. The two-seat MiG-29 Ube was helpful for pilots retraining for the new fighter. Of course, just because the aircraft had gone into squadron service, it didn't mean that development stopped. For instance, the early production MiG-29s had shorter range than had been specified in the operational requirement. The next version, the Mark 913, had almost 100 kilometers more range than the early ones. They achieved that by increasing the fuel tank capacity. They updated some airborne equipment as well. As radar technology had advanced, electronic countermeasures, ECM, had become more important. Tactical fighters started getting ECM. On the MiG-29, it was installed behind the cockpit, giving the aircraft a humpback look. This is the so-called fuselage spine fairing. ECM transmitting and receiving aerials are located in different parts of the aircraft, for instance, in the wingtips. The transmissions send out jamming signals which blind enemy radars and their missile seeker mechanisms. Another modification was for the defensive systems. This mod was not so secret. We even see it demonstrated by the Swift's aerobatic team. These flares are so-called expendable target decoys. Soviet aircraft actually had similar systems in the 1980s as a result of experience gained in the Afghan wars. The Mujahideen had begun to use heat-seeking missile systems, and these decoys were designed to provide protection from that sort of weapon. The MiG-29 has 2 flare dispensers, each carrying 30 cartridges. When the cartridge burns out, it creates a thermal spot where the temperature gets to about 3,000 degrees Celsius. That's significantly hotter than the temperatures in the aircraft engines. The missiles are decoyed away from the aircraft so that they explode harmlessly. So that's the MiG-29 fighter. By the late 1980s, it had got ultimate recognition and high credibility. Production was increasing. Not only that, but exports were beginning to some countries friendly to the Soviet Union. But the West knew little of what the aircraft was really capable of. That situation was to change suddenly.